Hey, this is Don from Padlock Technologies again with another video. This time we're going to talk about SD-WAN, but not traditional SD-WAN. We're going to talk about SD-WAN on secure firewall. Let me get this right out the way right now. Is it as robust as Catalyst SD-WAN? Absolutely not. But for the majority of people who want to get into SD-WAN, this will satisfy your needs. Okay. Most people, they don't have the internal staff to really take advantage of a Catalyst SD-WAN fabric build. Now, if you need help with that, links in the description. Other than that, if you are, you manage some firewalls and stuff like that, this will actually give you the SD-WAN capabilities that most people need. But if you need anything past, probably basic to intermediate stuff, you probably should go directly to like a full dedicated SD-WAN solution. Okay. So I did a video on it on route-based VPNs because this is technically what it does behind the scenes. But I did a video on route-based VPNs. If you want to see that video, it's probably going to be somewhere over there somewhere. You can check out that video on how to do route-based style VPNs on Cisco Secure Firewall, and then come back to this because this is kind of like 2.0 of that video. So let's go ahead in the lab, and then we'll go and I'll show you how to do it. All right, so here is, Catalyst dashboard. Not Catalyst dashboard, what am I talking about? This is a FMC, but we just saw, I don't know why that just disappeared on me, but let's log into the lab. Eve is acting funny. Come on. All right, so we saw this in every video, basic lab setup. So as you can see, and that Palo is still turned on. I didn't turn that off. We have a bunch of FTDs here, all right? Bunch of FTDs. Now, what we're going to do is this FTD here, which is DC1 FTD, we're going to treat it as the hub. Now, before you probably ask this question, what is the difference between normal route-based style VPNs and SD-WAN topology in Cisco Secure Firewall? Well, the difference is there's a lot of manual work if you're just going to do the traditional route-based style VPN. When you do SD-WAN, you actually create a pool and it automatically creates the tunnel addresses. It takes it from the pool, but it automatically creates the tunnel interfaces. It IPs it, it puts it into the SD-WAN fabric, and then you're almost there. Now, there is something that I'm going to point out with this that you need to be careful of because it doesn't set up, you can set up BGP, and it sets it up, but it's not fully configured. Now, every example I've seen of this, it's very generic. The BGP is set up, and it doesn't take into account if you're using a routing protocol downstream. Now, in this setup, I am using a routing protocol downstream. So I'm going to show you what most people are not showing you when they demo this. Okay. So basically, I'm going to create an SD-WAN fabric under the hood. If we're talking about technologies, this is going to be VTIs. This is going to be BGP over the top. The hubs are going to be treated as route reflectors. There is some community values that you're going to end up configuring on here, and I'm going to tell you a little gotcha about that as well. And everything's going to be IBGP. Now, the gotcha on that is when you're doing redistribution, and I'm going to show it to you. There's something you have to do when you do IBGP when you want to redistribute it into an IGP. If you know what that is from regular routing, put it in the comments below and I'll like the comment. All right. If you don't, you're going to learn it today. And this goes with this setup or just normal BGP routing. I don't recommend you doing it in BGP routing for certain reasons, but you may have to do it, right? And that's a CCIE kind of topic thing. So let's go to the dashboard here. Now, if we go to devices and then site to site, as you can see, I have a SD-WAN topology here, and you can see by the name of SD-WAN topology. Now, it's already created, but what I'm going to show you is if you go to add, this is where you get to pick what you want to do. Now, if you notice, that SASE topology one was grayed out and then it popped up. The only reason why I have that ability to do that is because I have integration with Umbrella on the back end. So this allows me to do the SASE tunnels and all that stuff, or SASE topology with Umbrella I believe I have a video on that. If I do, I'll put it up here as well, so you can see that video. But policy-based VPNs, that's the old legacy style crypto map VPNs, which I do not suggest anybody use nowadays, but it's backwards compatible with ASAs or anything that needs to do, legacy-based, policy-based VPNs. Route-based VPNs are the new hotness that every vendor does now, especially if you're going to go to the cloud. You're probably doing a route-based style VPN with BGP over the top. That's the new hotness. Most people should be going to that, right? And then we have SD-WAN topology, which is what we're going to do today, which is basically going to build an SD-WAN fabric amongst all your FTDs, and then it'll do the dynamic routing, and it does application awareness as well. So you can do PBR for certain type of protocols to go to different hubs. So that's where the SD-WAN stuff comes in. Now, when we look at this, this looks like normal, route and switch. I did a hub and spoke video as well. Look on the channel for that. This is the normal setup, but the difference is when I hit this edit button, it looks completely different from a route-based style VPN, policy-based style VPN, and a SASE topology. So let's hit the edit button here. And this is the screen that comes up when you initially try to create it. So I'm going to walk you through this. So the first thing you need to do is create the hubs. Now, there is a difference between traditional route and spoke for route-based VPNs and this. When you use route-based VPNs and you try to do hub and spoke, you have to actually do a loopback address and then borrow the loopback address for your VTI. With this, you can just create a static VTI without borrowing from a loopback, and that's what I did here. Now, what you do here, and I'll hit edit so you can see it, is you will say, hey, this device is my hub, which is my DC1 firewall. If you had DC2 firewall, that would be another hub with a different address pool, right? So you're going to create your VTI. Obviously, this is the underlay address. Anybody that knows anything about static VTIs, DMVPN, Flex VPN, any of that, you know what the underlay address or the NBMA address is. And then the pool. So this pool is an address pool, similar like if you would do it with an RAVPN, and it's going to assign the spokes a IP address when it dynamically creates the VTI. It's going to take out of this pool and assign an IP address, sort of like RAVPN. When you connect to the RAVPN, you get an IP address from a pool, unless you're using DHCP to control DHCP assignment or address assignment. So once you do that, this is the cool part. Now, this is why you would do this instead of route-based VPNs, because it's going to eliminate a lot of the underlay, like the initial setup. Because if I had a new spoke that I wanted to add to this, what I would do is hit this add spoke button, and it will say, hey, what device do you want to add? And then it's going to say, what is the VPN interface? Now this is going to look for my outside interface. It has to be named outside. If you named it WAN, you would just say it was WAN, and then it would look for an interface in WAN or called WAN or naming pattern of WAN, and then that will be the overlay to underlay configuration that's getting ready to happen. So it'll assign the overlay address to the interface that is named outside. And as you can see, I have a whole bunch of these in here, right? Now, when we talk about onboarding a branch, all you really need to do, and this is where we couple this in. Now, if you use templates, I believe you can assign an SD-WAN topology to a device template. So really, this is really zero-touch provisioning in a nutshell, in a box, like branch in a box kind of zero-touch provisioning thing, where you would create your template, you would assign the SD-WAN VPN to that template. All you would really do from you do bootstrap configurations to get it to talk to wherever it needs to talk to, whether it's, cloud delivered FMC, or you poke the firewall, hole in the firewall to get to your on-prem FMC, really doesn't matter. In this situation, I would probably use cloud delivered FMC. And then once you assign that template, it gets pushed to everything from a policy standpoint, platform configurations, device configurations, and the SD-WAN topology configuration. So I would say you could probably get a firewall up and running if you create your templates and everything correctly in maybe 30 minutes when everything is pushed down and then you validate that everything's on the fabric. and then the routing is everything to go. So let's say in half an hour to an hour, and the extra 30 minutes is for like validation to make sure everything is up and running. But again, this is auto created. So it just generates the interfaces. So if I say view generated interfaces, these are interfaces that were auto generated out the pool. As you can see from my Canada firewall, it looks for an interface called outside. That's the underlay, and it created this static VTI called outside static VTI1, and it assigned it an address from the pool. So my pool starts at .10 and then it goes to .100. It pulled .11, .12, 13, 14, etc. all the way down. So then the next thing it does is ask for your authentication. Now, you can manually set the key if you want, or you could do automatic key. If you have all FTD firewalls, you really don't care about the key. Let's just be honest here. Just most people, I mean, if you're a stickler for control, then you're gonna manually set it yourself. But if you're doing this type of topology, I just leave it on. Hey man, automatically create the key. I don't really care. It's using the GCM ciphers for the IPsec phase 1 and phase 2. So which is ICAV2, and then the transport set, which your IPsec IPsec proposal is your phase 1, and your ICAV2 policy is phase 2. But whatever. It's still using the GCM ciphers for that. So, that's the latest and greatest when it comes to encryption algorithms, are just protocol suites in general. And then I'm having the pre-shared key length 24. If you know anything about key length, the longer the key, the harder it is to crack it. So don't have short keys, put it like that. The key is really like the magic behind uh, encryption. Algorithm is cool, but the key length is really important. Next, this is the one that you got to look out for. So the next one is the SD-WAN settings. Now, I already had this security zone called RBSDS from my last video about route-based VPNs. So I'm just using the same. So these interfaces that are auto-generated will automatically be in this zone. And if you see in my ACP policy, which I'll show you, I'm just allow anything for right now for this example. But here is the rub. So enable BGP overlay VPN topology. So you got to give it an AS number. That means everybody in this fabric will participate in the same ASN. So that makes it IBGP. Okay. And then this community tag, what it does is behind the scenes, it creates a route map that only sends these, and any route that's set with this tag will get redistributed out to everywhere else. It does not automatically send out routes with this tag. And that's the gotcha. So when you redistribute the routes, or when you statically assign the routes, you have to assign it with a route map so that it advertises it out to everybody else. Or you'll notice that at the other sites, you don't see the routes, especially when you redistribute BGP back into your IGP. But remember, it's IBGP. So what do you have to do? This is for my, CCNP, CCIE people. Put the answer in the comments. I better see some right answers, or you're gonna have problems. But I know I'm gonna tell you anyway. So just make sure you put it in the comments. So you got to be careful with this, because you're thinking that, hey, I'm going to advertise this route with the community value. No, it's actually saying, hey, only allow routes with this community string to be advertised to the neighbors. So that's what messed me up, like the first time I actually did this in real life, because I thought, oh, I'm just going to advertise this with this community value, and that's not it. Now you have those redistribute connected interfaces. Why would you do that? I don't know, but it's an option to be there. And all the examples that I've seen, and even like demos I've seen, they always click this because they only show you like, oh, you can look at the routes for my connected interfaces are in BGP. But in the real world, you're normally not advertising your connected routes per se all the time. It's usually you're advertising downstream routes into BGP. And then after you hit next, it creates this fabric. So it creates this fabric, and you see all my tunnels are up. Everything's good to go. Now, let me tell you about the routing part. So you saw us at BGP and all that good stuff. Well, here's the thing. When you actually go to one of your routers, and I'm going to go to the hub here, when you go to one of your routers and you go to routing, what I noticed is BGP wasn't enabled. Like all this was turned off. So I had to actually go in there and configure it correctly, right? Like configure BGP, configure redistribution on both, or mutual redistribution between OSPF and BGP, which is what I'm running right now on the DC firewall. Everybody else is doing EIGRP. But I had to go in here, assign it the ASN that I said I was going to assign in the SD-WAN fabric. Then I had to go to IPv4, and here's the answer to the question if you didn't answer it in the comments below. When you have BGP and you're redistributing those routes into IBGP, from IBGP to from IBGP to IGP, you have to use BGP redistribute internal. If you don't use that command, it will not redistribute internal BGP routes into IGP. Now, the reason why you don't want to do that is because you can break your IGP, because IGPs aren't built to handle a plethora of routes. So if you're going to do that, you're going to use a route map to determine what routes do you actually want to redistribute into your IGP so you don't break your IGP. And that's the answer. I hope you put that in the comments, because if you don't, you need to start reading Routing TCP/IP Volume 1 and 2. That book, those two books will make you cry, but it will make you smart. So we have it here, redistribute IBGP into IGP. So that's going to help me redistribute my routes from my, SD-WAN fabric to the data center. And I'll show you that when I look into the core switch. And then from a redistribution standpoint, am I redistributing? Oh no, I'm not redistributing any BGP routes from OSPF into BGP in the data center. What I'm doing is I'm advertising those routes with this route map. And this route map says, hey, set the community value to 9998. So let's go up in here and I'll show you that. So here's the route map. Here you go. Route map sequence 10. And by default, sequence 20, which you don't see, is implicit deny. So as you can see, we're going to our set clause and our BGP clause, go to our community list, and there you go. So we're going to set any value that I use this route map on is going to be set to 9998, and then it will be allowed to be sent to my spokes in my SD-WAN fabric. So here's another side quest that I want you guys to remember. You still need routing fundamentals to properly work a firewall, right? It's not just a security appliance, and you just strictly focus on ACP rules and or whatever vendor you're using, or you just can't focus on that. You still need to know some routing fundamentals to truly master a firewall, right? Because a lot of people don't know how to manipulate like routing on a firewall because they don't have the routing fundamentals, or they're strictly just a security person. That will burn you in the long run. Don't just learn how to secure something, learn how it works, right? And then learn how to secure it. That's going to help you. So back to this, I'm advertising these routes with this route map, and that's when it's going to allow it into the fabric. Now, I'm going to show you something cool on Cisco Secure Firewall. Oh, let me show you the OSPF side. So OSPF side, we're good here. And as you can see, BGP is being advertised into, or my IBGP is being advertised back into OSPF. Since this is a small little demo, I don't have to worry about using a route map to specify what routes there are, because it's not a whole bunch of routes. So back to the devices here, I'm gonna show you how to get to a better CLI than the troubleshooting CLI that normally, like this CLI, where is it at? This threat defense CLI, don't ever use this. This is it's very limited and it doesn't really look good. If you go to the devices and you click this CLI under troubleshoot, gives you a way better CLI, right? So we look at show run route map. Now, this is what I was talking about. So as you can see, here's my route map that I created, but this is the route map that gets sent out to people or sent out to my spokes. So as you can see, it says match the community value, and this is just the community value that it created, 9998 exact match, set a metric of 1, and set the next hop to me. That's what the route map is technically doing. Now, if we look at our BGP, BGP, I never can do it that way. So we look at our BGP, here's that community out, right? That community value that it is looking for to send it out, right? So if I don't actually set a community value for any route that I'm redistributing, it's not sending any of those routes out. See, they don't, I've never seen somebody in any videos point this out. And you will get burned if you do this in real world and you're like, why do I not see any routes in my fabric, right? You're going to run into problems. So hopefully you guys are seeing this now, and you won't get burned. So BGP IPv4 unicast. See, I tabbed thinking I was going to get constant sensitive help. That's I've been in the CLI too long. And these are the BGP routes that I'm learning from my spokes and everything else. All right. So that's the fabric. I'll show you one spoke so you can see it from the EIGRP side. Let me do Boston here. So from the routing side, BGP is already set up the same way. Here's my redistribution though. I'm redistributing the EIGRP with that route map that's setting it to 9998 so that I actually advertise it into BGP. And then from the EIGRP side, from a redistribution standpoint, we're doing the same thing. Now, what is the difference? Here's another routing question. What is the difference when you're redistributing the OSPF versus EIGRP? Comments in below. Put the comments below to answer that question. I'm kind of already showing you it, but let's see if someone's paying attention to the video. And then if we go to the CLI here, and what I mean by that question is what must you do? Okay, and if you don't do it in the EIGRP, you won't see the routes. So we go to show BGP IPv4 unicast. Where am I at? Let me see if I actually got appearing here. Oh, this is. Why did I do that? What am I running on here? I don't think it takes the SH. There we go. So here's my routes. See, that's how you know you've been in the CLI too long. You start shortcutting stuff, and you can't. Next thing you know, you get those error messages, and you're like, "No, I know that command works 100%." So let's go a BGP standpoint. Here's all my BGP stuff here. All right. Now that's all good and plenty because it's on the, you know, device itself. But let's look at it from the core standpoint. So I'm gonna go to the core here. What are we doing? And let's just do show. I'm gonna do show IP route OSPF because it's gonna be it's gonna show up as an N1 route, and if it's an N1 route, what area did that come from? That's another question. So here's all my N1 routes, and I believe 10.100 1.24. I believe that's coming from. Where's it at? That is coming from the Chicago one. So we go to Chicago. Now this is going to be EIGRP. So if it's EIGRP, what should it look like? What should it be, a D or a DX route? It's a DX route. So here's my DX route for the data center. These are my data centers here. 170, 172, 173, 174 is in my data center. So technically, if I ping, let's look at what the VLAN 1 is here, so I can make sure I got the right address. Run. All right, so it's 10, 100, 1.254. So if I ping 10 from my data center, 100, 1.254, and I source it from VLAN 173, we have connectivity over the SD-WAN fabric because that ping actually went through. And if you don't know, let me just show you that in the data center. Oh, wrong. There we go. So I pinged from here to Chicago, VLAN 1, and that went perfectly fine. Now, that's the SD-WAN fabric topology in a nutshell, but the last thing I want to show you is they have a specific menu for SD-WAN. So if you go back over here and you really want to take a look at it, and it's a cool menu, by the way, you go to Overview, SD-WAN Summary, and that's what it looks like. So this tells you, throughput, what kind of models of devices you're using, the WAN health, the connectivity. Now you do have to enable path monitoring to see the WAN connectivity, health, and all that good stuff. The VPN, and it shows you the protocols that are being seen in the fabric, right? Monitoring that. Now, application monitoring, since I'm not doing PBR, it's not going to show, right? So there's really nothing here to show in application monitoring whatsoever because I don't have PBR. Well, actually, I'll be. It actually showed something. I must have not. They made me wrong because usually, because I didn't do this, and you know what's funny? I think I know why I'm seeing this now. Is because I had an issue on my laptop and I had to upgrade it, and it was something going on with Firefox. So I thought, hey, I'm not seeing this because of that issue, but apparently I can actually see it. But here you go. Here's some application stuff that you can see that you won't see when you do traditional route-based VPNs. That's why the SD-WAN topology, if you're going to do it amongst your own devices, right? You own these firewalls. I would go with the SD-WAN topology versus route-based VPNs. I will only do route-based VPNs when I'm doing it to another vendor or another, company that you're sharing data with. You're doing a VPN with them unless they're doing policy style. But I would always do SD-WAN for these capabilities and the ZTP function of, hey, just adding devices to the fabric without any problems. So this is Don from Padlock Technologies. I hope you liked this video. It was very long-winded, had some questions there as well. Put the answers in the comments if you didn't already. If you like videos like this, don't forget to share, comment, like, and subscribe to the channel. My channel is growing, and I really appreciate everybody that's viewing the work that I'm doing because it lets me know that I'm not the only geek out here, right? Again, I hope you enjoyed it. Share this on your socials. Thank you, and have a nice day.